Lesson 2.9, we're going to look at analyzing linear equations, y equals mx plus b. So we've been doing equations. We talked about y equals kx, which was proportional. We talked about y equals mx. M was our slope, which was also proportional. Finally now, we're going to talk about what happens when it's not proportional. Okay, so y equals mx plus b is the equation we're going to be looking at. The m is still going to be our slope, and what we'll learn about today is that the b, we looked at it a little bit in the last lesson, the b is going to be our y-intercept in our equation. So on page 141, so we have Zhu and John take the tram from the base camp to the mountain summit. After about 6.5 minutes in the tram, John says, cool, we are a mile above sea level. Zhu says we passed the 1 mile mark a couple minutes ago. So construct an argument to defend Zhu's statement. So looking at the picture, a couple things to make note of. We have the mountain lodge elevation of 2,080 feet here, where the red dotted line is. That is the starting point. That's where they're starting at. And then you can see that the tram is going at a speed of 800 vertical feet per minute. So in other words, it's not just going straight up 800 feet, but in a minute's time, you know, it's going horizontally some, but it's also going up, climbing by 800 feet every minute. So the summit elevation at the top there is 9,600 feet. So since we're trying to get to 5,280 feet, we're starting at 2,080 feet. If you subtract those, that's going to tell us how much further we have to go. So that tells us we are going to need to go 3,200 feet further from where we started at. And then since the tram's going 800 vertical feet per minute, if we take 3,200 divided by 800, that's going to tell us how many minutes that's going to take. So when you divide that as 4, and that means that it would take 4 minutes for us to get to that 5,280 foot mark, which is our mile above sea level point. And so that confirms what Zhu said, you know, 6.5 minutes, you know, that's already 2.5 minutes past when they actually got to that point. So basically the problem is what John did is took the 5,280 divided by 800, and just that would tell you if you were starting at sea level, right at sea level, how many minutes it would take to get to the mile mark. We're not starting at sea level though, we're starting at 2,080 feet. So that's why it's not taking us as long to get to that point. Example 1, the middle school student council is organizing a dance and has $500 to pay for a DJ. DJ Dave will charge $200 for a setup fee and the first hour, or $425 for a setup fee and 4 hours. How can the student council determine whether they can afford to have DJ Dave play for 5 hours? So you can see here from his business card, setup fee is $125 and the hourly rate is $75. And that's very valuable information right there, actually. That's more valuable than the information that they told us in the problem, actually. So what that tells us, what we're going to be looking at, is we have an initial value or initial fee, which is the setup fee of $125. Okay, so kind of like we talked about in the last lesson, that initial value, that starting value, is the same as our y-intercept. So if we go to graph this, one point on the graph would be the point 0125. All right. The book chose basically they're going by 50s on the y-axis. If you wanted to go by 25s, you could. So 0125 would be 1 point. And then since it told you that the hourly rate is $75, you could go up 75 and over 1. Just looking at this again, I think what the book's trying to do, they didn't do a real good job of it. I think they're trying to actually act like we didn't have the information on the card, okay, which is kind of difficult to do. We've got this big card with this information, but looking at this again, I think that's what they're actually wanting us to do. So they're wanting us to say 1 hour, it costs $200. 4 hours, it costs $425. Okay, so a little bit different perspective now if we go that route. Basically, in that case, we would graph those 2 points. I don't like their upside down triangle here. But we could look at what our slope is. Remember, slope is change in y over change in x. So we could say our y's went from 200 to 425, so change in y. You can see they subtracted off to the side. That would be 225. And then the x's went from 1 to 4, so that's going over 3. So 225 over 3 would be our slope, and if you divide that out, you get 75, which tells us that the hourly rate is $75. And then graphing that, if you can graph it perfectly, you could maybe tell where this point is at. That's kind of a bad thing about trying to do it this way would be that if your graph's not exactly perfectly straight, we're not going to be able to tell that that's the point 0125. A safer way, I would say, is once you figure out it's $75 an hour, and we know 1 hour was $200, let's just back off $75 from that. Does that make sense? That's backing off 1 hour's cost. 200 minus 75 would be 125. And then for sure we know that we're going to be hitting at 0125. We know that we have that y-intercept is 125, which is the initial fee or the setup fee, as they're calling it here. Okay, it's really always safer if you can just work numbers out by hand rather than trusting your graph to be perfectly straight. Very difficult to draw a perfectly straight line, and even if you do, sometimes the points aren't exactly nice for you. Okay, if that's not a nice point, even if I draw a perfect line, I'm going to have a hard time determining what the point actually is at. So what this is talking about then, step 2, we can write an equation for the cost. So the equation we've talked about before, y equals mx, where m is our slope. And this is a similar idea to that, except for we have something else added on behind it. So like we did earlier in the chapter, we'd start, since our slope's 75, we could start with y equals 75x. But it's not going through 0, 0. It's not proportional. So it's not going to be just in that y equals kx format. So initial fee we figured out was $125, and that is our y-intercept. So in this equation, this y equals mx plus b equation, b is representing the y-intercept. So basically we're substituting in this equation. This is called slope-intercept form. We're substituting two things. M is our slope, B is our y-intercept or initial value. So like the name says, slope-intercept, we need the slope and we need the y-intercept, and then we can get our equation. So that's going to be a big part of what we're going to be looking at. So the final thought for this example then is, can we afford 5 hours? So once we get the equation, we could substitute a 5 in place of the x, work it out, and we get $500. Well, coincidentally, we had exactly $500, so we could exactly afford DJ Dave with nothing left over. Okay. Another way of doing this, what you could have done, probably a little quicker potentially, is that once you figured out it's $75, well, 4 hours was $425. Just add another $75, and that shows you 5 hours is $500. Okay, so there's lots of different ways that you guys could work this out and figure out the answer. Lots of different options here. So to try it, at the bottom of the page, they want us to write a linear equation in slope-intercept form for the graph shown. The first thing they want us to do is tell what the y-intercept is. So if we look at the graph, we've done this before. We can tell that our y-intercept is 2. In other words, the graph is hitting the y-axis at 2. Okay, so y-intercept is 2. That's one thing we have to find. The other thing we have to do is find the slope. And the book does a good job here of actually going up and over for a change. So change in y, change in x. So what they did is found another good point on the line, like right here at 4, 5. And then we just look at what's our change in y and what's our change in x. So change in y over change in x. So we're going up from 2 to 5, so that would be a change of 3. Okay, again, if you want to subtract 5 minus 2, you can. And then the change in x's, we're going from 0 to 4. So 0 to 4, that would be a change of 4. So up 3 and over 4, that means our slope is 3/4. So slope is 3/4, and the y-intercept is 2. And then we're just substituting in that formula. So I'm going to write up above here so we can see our substitutions happening. We had y equals mx plus b. And then we're just substituting. M is our slope, which is 3/4. B is our y-intercept, which is 2. So the equation of that line is y equals 3/4 x plus 2. Okay? With this information, you guys are now capable of actually coming up with the equation of any line, even if it's not proportional. Okay? It's pretty powerful stuff here. And again, it is called slope-intercept, so those are the two things you need to find. You need to find the slope, and you need to find the y-intercept of the line.